Up until now, the focus of our discussion with respect to circles has been on finding angle measure and finding arc measure. Today we're going to switch the focus of that discussion and talk about how to find lengths of line segments. We're going to start by first talking about lengths of chords. To remind you what a chord is, it's a segment that joins any 2 points that are on the circle. So if I take my circle and pick any 2 points anywhere on the circle and join those 2 points together, that blue line segment is a chord. A diameter is a very special type of chord that passes through the center of the circle. So I still have that same circle, still any 2 points on the circle, but in order to be a diameter, that chord must pass through the center of the circle. All right, so now that you're refreshed as to what a chord and a diameter are, we're ready to go on. The first 3 theorems that we need to talk about all discuss a radius's relationship with a chord. The first one says anytime you have a radius that's perpendicular to a chord, the result is that that radius bisects the chord. So in picture terms, what we're talking about here, they're saying that if this radius, OC, is perpendicular to this chord, AB, it will bisect chord AB. So what that means is that it will cut chord AB into 2 equal parts. The converse of that is true as well. Anytime that you have a radius that chops the chord into 2 equal pieces, we know that the radius and the chord have to be perpendicular to each other. And then the last one kind of ties both of those together and says that the perpendicular bisector of a chord has to be passing through the center of the circle. The next one is kind of a common sense theorem. It says anytime you have congruent chords, they're equidistant from the center of the circle. And likewise, 2 chords that are equidistant from the center are going to be congruent. So here's what those theorems are saying. They're saying if the distance that these chords are away from the center is equal, then the lengths of these chords must be equal as well. And anytime you know that these chords are equal length, it must follow that they're exactly the same distance from the center of the circle. The next one is one of my favorites because it just seems to be very intuitive and it just feels like it works like it ought to. It says anytime you have chords that are parallel to each other, they're going to intercept congruent arcs. So what this is saying is that if these 2 chords, A, B, and C, D, are parallel to each other, then it must follow that arc AC and arc BD are also the same. And then the last one that you need to be aware of talks about 2 chords intersecting inside the circle. It says the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other. All right, so in mathematical terms, here's what we're talking about. I have a green chord and I have a blue chord. They intersect inside the circle. What this theorem says is if I take the 2 segments of the blue chord, so part A and part B, and multiply those guys together, that product is the same as if I multiply the 2 pieces of my green chord, C and D. So in other words, A times B is equal to C times D. All right, so let's go see how we might use some of these to solve some problems. In this first example, it says to find X. What we're looking at here is something very similar to that last example that we just looked at, where we have 2 chords that intersect inside of a circle. I'm going to make them yellow and blue. We know that the product of the 2 pieces of the yellow chord has to be equal to the product of the 2 pieces of the blue chord. So in other words, 12 times X has to be equal to 8 times the quantity X plus 2. So when I apply a little bit of distributive property to the right-hand side, we end up with 8x plus 16. I'm going to subtract 8x's from both sides, divide both sides by 4, and as a result, we find that the value of x is equal to 4. All right, moving onwards, number 2 is a little bit different and unique and special in that it's the only one that we're going to take a look at today where they don't give you a diagram. Because they don't give us a diagram, the first thing that I'm going to do is draw one. So it starts out by talking about circle O. I'm going to draw a nice circle. Its center is going to be O. It says diameter AB, so I can draw my diameter wherever I want, as long as its endpoints are on the circle and it passes through the center. It says is perpendicular to chord CD. So I can put chord CD wherever I want, as long as it's perpendicular to that diameter. And I guess I forgot to label my diameter. I'd better do that. And it says the point where they meet is point E. So I'm going to label that point E. Oh, and I'm going to go ahead and I know automatically that because this green guy is a diameter, that's going to make OA a radius. Because he's perpendicular to my blue chord, I know that he has to bisect my blue chord. So I'm going to draw those equal parts. I know that the length of C to D is 20, meaning each one of those pieces has to be 10. I'm going to label that in my picture. B to E is 2. And the distance between points A and E is 4x minus 2. They want us to find the length of the diameter. Like the first example, I have two chords that are intersecting inside my circle. One is blue, the other one is green. I know that the pieces of the blue chord have to be multiplied together, have to be equal to what I get when I multiply the pieces of the green chord together. So I'm going to go ahead and write an equation that reflects that. So the two pieces of the green chord are 2 and 4x minus 2. Their product must be equal to the two pieces of the blue one, 10 times 10. Again, I'm going to apply the distributive property. And I mentally add 4 to both sides. 8x is equal to 104. I'm going to divide both sides by 8. And I find that the value of x is equal to 13. Now that's all very well and good, but if I look back up in the directions for the problem, it doesn't ask me to solve for x like with the first one. It asks me to find the length of the diameter. So I'm going to have to go back through and plug in. 4 times 13 is 52. 52 subtract 2 is 50. So my picture is indeed a very poorly drawn picture, but it still helped me to solve the problem. So the length of the diameter is going to be this distance from A to E, 50, plus this distance from E to B, 2, or 52. All right, moving along to the next one. This one's going to be a little bit more straightforward, and all they're asking us to do is solve for x. I've got this piece right here that's perpendicular to this chord. Automatically, I know that it has to bisect that chord, or in other words, cut that chord into two equal pieces. So 2x is minus 20. The one piece of the chord is equal to x plus 6. The second piece of the chord, I'm going to subtract x from both sides. I'm going to add 20 to both sides. And when all is said and done, we see that the value of x here is equal to 26. All right, number 4. Chords A, B, and C, D are parallel. So I know automatically, this is my favorite theorem. If these two chords are parallel, I know that the arcs they intercept, which are the blue ones, have to be equal. So if this blue arc measures 80, this blue arc over here also has to measure 80. The arc from A to B, and notice that these didn't copy so well, so there should be a little arc symbol there, is equal to 60. That's already labeled in the picture. Measure of arc AD equal to 80. That's already labeled in the picture. And what they want us to find here is the measure of this arc from C to D. Well, looking at the picture, it looks like we have all but the arcs that we're missing for. I know that in a circle, the sum of all of the arcs has to be equal to 360. So x plus 80 plus 60 plus 80 has to sum up to a total of 360 degrees. So in other words, x plus 220 has to be equal to 360. And when I subtract 220 from both sides, x has to be equal to 140. So the measure of arc CD, that's the same as x, and that's equal to 140 degrees. All right, number 5. This one too deals with my favorite theorem. We've got those parallel chords. Anytime those chords are parallel, we know that the arcs that they intercept must be congruent. Since the arc from B to C is 30, the arc from A to D must be 30 as well, so I'm going to go ahead and label that in my diagram. They tell us that chords DE and CE are congruent, so I'm going to go ahead and mark that in my picture. And if these two chords, well, I'm going to leave that alone for right now. And then the measure of arc from A to B has to be equal to 50 degrees, and they labeled that in our picture. So let's see, they want us to find, and this should be the arc from D to E. I think in this picture, there's a couple different ways that you could start this and be right about it. I think I'm going to focus on this little triangle here. He's an isosceles triangle because he has two sides that are the same. His base angles are going to have to be congruent. And if those inscribed base angles are congruent, I know that their intercepted arcs must be congruent as well. So I know that arc DE must be the same as arc EC. You might have gotten that right from these congruent chords here. These congruent chords would force the arcs to have to be congruent. However you want to think about that is entirely okay. I'm going to let these guys each be x. And again, I know that the sum of all the arcs in my circle has to be equal to 360. So x plus 30 plus 50 plus 30 has to have a grand total of 360 degrees. So 2x plus 110 equals 360. I'm going to mentally subtract 110 from both sides. On the right side, I might do 360 minus 110 on my calculator. Divide both sides by 2. X comes out equal to 125. They're asking me to find the measure of arc DE. That is the same as x, or the 125. All right, number 6. Oh, my favorite theorem again. So this one has those parallel chords in it. Because those chords are parallel, the arcs that they intercept are going to have to be congruent as well. But they don't tell me the measures of either of those two arcs. So I'm at kind of a dilemma till I start to examine my picture a little bit closer. I notice that the measure of this central angle is 40 degrees. I also remember that the measure of a central angle is equal to the measure of the arc that it intercepts. So because this central angle is 40, I know that this red arc must also measure 40 degrees. This red arc over here must also measure 40 degrees. And now I've put myself in a very nice position where I can just again sum these all together and set that sum equal to 360. So if I clean up the left-hand side by combining the like terms, I end up with 240. So the value of x, therefore, must be equal to 120. All right, if after watching the video you have questions or there are things that you don't understand, now would be a good time to jot yourself a note so that you'll remember to ask me about it the next time you come to class. And when you come to class, we'll practice on working with some of these rules and properties and theorems.